First of all, let us establish the relationship between the accelerations of blocks m1 and m2. We can use our string constraint motion technique to find out the relation. So let us say that m1 moves a distance x like this. So we will need 3x more string. But as we have already discussed, that in the cases where m2 is also constrained to move together with m1, this part of the string will be compensated by this movement of m2, so that both m1 and m2 are together. So the net movement of m2 relative to m1 will be 2x upwards. Looking at the situation, we can say that the movement of system will be like this. So if m1 has acceleration a towards right, m2 will have an acceleration a towards right, and 2a downwards. Let's consider the free body diagram of m1 and m2. For m1, along with the pulley, we have set of 3 tensions from the rope, normal reaction from m2, friction between m1 and m2, downwards, friction from ground towards left, and we have weight of m1, and normal reaction from the ground. So writing equations, we get n1 is equal to m1g plus t plus f1, and 2t minus n2 plus f2 is equal to m1 into a. Since we have assumed that our system is moving, we can write friction to be equal to mu into n. Now for m2, we have tension T from the rope, friction between m1 and m2, normal reaction between m1 and m2, and weight of m2. So writing equations, we get m2g minus T minus mu1 n2 is equal to m2 into 2a, and n2 is equal to m2 into a. Using n2 from this equation, we get m2g minus T minus mu1 m2a is equal to m2 into 2a. Therefore T is equal to m2g minus mu1 m2a minus 2m2a. Substituting n1 from this equation into this, we get 2t minus n2 minus mu2 m1g plus t plus mu1 and 2 is equal to m1 into a. Substituting the values of n2 and t from these equations and solving, we get a to be equal to b this term.